All right, now we're doing 7Q number of rectangles in a grid. This is by PJ6444, and 84% of the people like it. Given a grid of size m times n, calculate the total number of rectangles contained in this rectangle. All integer sizes and positions are counted. Right? Here's some examples. 3, 2 will be 18, 4, 4 will be 100. How it works is there will be one rectangle the size of 3, 2, two rectangles like this one and this one, this one and this one, of 3, 1, 3 times 1, 4 rectangles of 2 times 1, so 1, 2, 3, 4, and then so on and so forth, all the way down to 6 of 1 times 1, 1 by 1, I should say. Anyway, that being said, if we just look at it like this, it's going to be 1 times 1, 1 times 2, and then it'll be like 2 times 1, 2 times 2, 3 times 1, 3 times 2. So we can just do it like 2 for loops together, taking care of this, and then just add them and then just sum it up. So that's what we're going to do. We're going to say let result equal 0, right? And then we're going to do a for loop, and we're going to say let I equal 1, because we don't need to get any zeros in there. All right, so let I equal 1, and we're going to say while I is less than or equal to m, we're going to say I plus plus. I plus plus. And then down here we're going to say for, and then we're going to do the same thing for j. All right. So we just change these all up to j's. And in here. All right. So now we're going to say, well, this is easy. We're just going to sum I times j, and that's it. So we're going to say result plus equals I times j. All right. Down here we're going to return result. All right, let's test it out. Works. 1 millisecond on the test. On the real deal, 51 milliseconds. All right. that's long. Anyway, yeah, we've got a concise method here that's a little bit shorter. So we're going to say const, a little bit shorter to write, and speed-wise too. And we're going to turn all this into an arrow. All right, now I don't know how this formula came about. I just saw it after I put in my other answer. Yeah, it goes like this. We're going to do m times n times plus plus m times plus plus n, and then divide it by 4. And for some reason that I'd probably have to have some sort of visual aid to understand what's going on here, but for some reason this works, because watch, and it goes fast, because we just beat this one by what, like 48 milliseconds. Yeah, so all right, I'm going to submit this one. No, I should have. Too late. All right, very much like this one. My solutions, just me on this one. Best practice in my opinion. And we'll see you next time.